Okay, so we've talked about some different types of root systems of plants, and I've shown you some pretty cool slides. But now I want to talk about the extent of the root system, the overall size of the root system, the depth. I want to tell you about one particular experiment. I think you're going to find this pretty amazing. Okay, so there was this scientist. This very meticulous scientist decided that the best place to see a whole root system, to actually see how big the entire system got, the best place would be to grow it where?
Water?
In water. So he took rye plants, it was rye plants, and he started growing them in water. Now, you've all heard of growing stuff in water before, right?
It's done commercially, right? Like to grow vegetables and flowers?
Right. They grow all kinds of commercial crops in water. So, if you're growing things in water, you can add the fertilizer. What do you need to do to that water besides put fertilizer in it? Anyone ever actually tried to grow plants in water? You must bubble water through it. Bubble gas through it. I'm sorry, you must bubble gas through it. So, gas, you have to bubble through. Think about the soil we talked about last week, about growing plants in soil. Think about some of you who have killed your favorite houseplants because you love them too much. If you overwater, why do your favorite houseplants die?
Oh, no oxygen.
Not enough oxygen for the roots. Which do what 24 hours a day, in all seasons?
Respiration?
Respire, respiration. They breathe. So if you just stick rye plants in water, it doesn't make a difference how much fertilizer you add. You also need to bubble gas through the water. So they have access to that oxygen. If they don't have that, they're in big trouble. Okay, so this guy, this scientist, grew a rye plant in water so he could see the root system, how big it got, its surface area. I read about this, and the book said 1,000 kilometers of roots. I kept thinking, this has to be a mistake. It just doesn't make any sense to me that could be right, but that's what all the books have, and no one's ever corrected it. So let me explain to you about this rye plant. If you take a little seed of many grasses, and remember, rye is a grass. If you take a tiny little seed and you germinate it, actually, take one of my least favorite grasses that starts growing about May. What's my least favorite grass that starts growing about May?
Crabgrass.
Crabgrass. Remember how I showed you in the lab, one little seed starts out producing one little shoot, then at a week or so later, you've got about 6 shoots. And then 3 weeks later, you've got about 15 shoots coming out all directions, like this. All those little shoots up there? Well, that's what they did with the rye. And the little seedlings started, and pretty soon there were several shoots, and then more shoots. In the end, that one single seed produced 80 shoots, with an average of 50 centimeters of height from one seed. 80 shoots coming out. Average 50 centimeters high. When they looked at the shoot versus the root surface, they found that the shoot surface, with all of its leaves, had a total surface area of about 5 square meters. Now, here's the biggie. When they looked at the root surface area, you would expect that the root and the shoot would be in balance, right? So they should be pretty close in terms of surface area, right? What's that? Did somebody say no? Well, you're absolutely correct. Instead of 5 square meters, the root system was found to have more than 200 square meters of surface area. Where did all of that extra surface area come from? Who did it? Who was responsible for all those extra square meters of surface area? What did roots do to increase their surface area?
Root hairs.
Root hairs, that's exactly it. So those root hairs were responsible for an incredible chunk of surface area. They constantly have to be spread out in the water so they can absorb minerals from the fertilizer. And of course, they need oxygen access as well.